It's 8:30. So the charging current now is 6 amp. So it'll increase um, into the day. I have to go somewhere, so when I come back, I'll check it again. So it's 8:30. So it's 9:30. Now the current being pushed into the battery is 8 amps, which is good. So if it goes to 10, but then it follows bell curve. So, but this is good news. So the PV is increasing, of course. But look, there are 3 bars. It's going up to the last bar. So we'll see as the current increases, the quicker the charging of the 150 amp hour will be. So for example, if it goes up to 10 amps, then 150 divided by 10, that's 15 hours. Today it's not going to be 15 hours, so today and tomorrow, depending on the condition of sun. So it's 9:30, so of course bell curve, I don't know when it would diminish, but it won't fully charge today. It would be, I don't think we'll be getting over 10 amps, but maybe this would surprise me. Let's see. So I'm doing a running tally of the current right now. It's 10 o'clock, so that is the charging current, 9 amps. That is the voltage from the PV. That is what it's measuring. Here, it's actually 28. So again, there's a DC component now. So let's see what it looks like. Oh, it's regulating it, but there should have been a AC component, but that's alright. It's actually taking the 28 volts and still having a 100% duty to the battery, and because it's from this cable to the PB, there's a 2-volt drop, and that is IR loss. So this cable, whatever, there's an IR loss. So and when you're doing this, make sure your cable do not have IR loss as much. And now the battery is at 26.8. This morning it was 24.9. Once it gets into floating charge, we'll see how that is. But it's looking good. So 1200 watts from the solar panel is actually what's going into the battery is 9 amps times 26. That is the watts. What is let's see, 200 watts. So the efficiency is not good. So if you think about it, 200 divided by 1200, take out the 2, so 2 over 12, 1/6. So you're only taking 1/6 of the 1200 watt into the battery. And so to mitigate that, you gotta add more solar panel. Again, I keep pushing more solar panel because that's the reality of it. The specification is one thing, practical putting that in practice is another thing. So it's 10 o'clock. The current being pushed into the battery is 11 amps. So with this kind of current being pushed, into the battery. Let's just say it's 10, but 150 divided by 10 is 15 hours. Uh, Now, of course, if it was 20, then it would be 7 hours. But I don't think we'll get 20. To get this 20, it would be another, actually 600 watts is 5 amps. And 1200 watts is 10 amps. So another 600, which is 1800 watts, then it would be 15 amps. So 2400 watts would be 20 amps. Yeah. So there you go. That is the solar capacity needed to quickly charge something. So that's what you have to factor into these things. Like, what does it take for things to happen? Now the PV is 12. It's like I said, 10 o'clock. So again, it follows the bell curve. I think if I wait long enough, 11, we'll see what 11 o'clock look like. So the more amps going into the battery, the quicker it charge. It's 11 o'clock. The voltage going into the battery is 26. It's a PWM. It's actually not 26. And the charging current is 12. So at this rate, let's just make it 10. So 150 amp hour divided by 10, so it's 15 hours. So if we look at, let's say we want to have 20 amps pushing into the battery, then you would at least need 2400 watts. So that's an increase of solar panel and solar energy capacity going into the battery. So that's basically based on this initial study. The more the solar panel, the quicker you can charge the battery. And to power up the house with solar and charge the battery, you would need to double that, 2400 watts. You would have to go 5 kilowatt solar panel, and I think that would be conservative estimate of what it takes to power up a house and charge a 150 amp hour. Anyway, it's an idea that one has to look into and say, yeah, how much would that cost? It's noon 12, so the charging rate is 13 amp and the battery voltage is 27. So how long will it take to charge the remaining capacity? I'll do that in Excel spreadsheet. I'll do that in I'll create a Excel and figure out what's left, or how I calculated when I was doing the sum. It's 1 o'clock. The charging rate is 13 amps. I think it plateaus at this current. And it's getting up to that floating charge, but it's not fully charged because the last bar is still blinking. So, actually, it's diminishing. It's fluctuating now. It's going into that floating charge because The inverter is now testing the cell. So it does that. It varies the current, and it does it by millisecond. If I was designing this, I would do the same. The firmware design would, I would turn off the power to the battery and check the battery level, and then not liking it, re-enable the charging. That's why it's fluctuating. It's going into the trickle charge mode, or getting into the full charge. So there's it seems like the minimum panel here is 1200 watts. So EV is 27. Yeah, we'll see what happens at 2 o'clock. It's 1:30. I have to go somewhere. I can't monitor this now. It's 12 amps still. The battery is 28 volts. It's getting up to floating charge. So it's almost terminating the charge at this point. I have compiled the charging rate of the at the previous time. So at 8:30 the charging current was 6, 9:38, 10:39, 11:30, 12, 12:30, 13, 1:30 is 12. So here, like I mentioned, it follows bell curve. So I multiply this number by 1 hour. So basically, multiplying a number by 1 is whatever that number is. So this is the amp hour then that went into the battery. Between 8 and 9:30s, the charging capacity, or the capacity that went into the battery, is 6 amp hour. So this whole thing combined or summed up, 60 amp hour went into the battery. Suppose, for example, the battery is depleted to 0, meaning that there's a voltage 22 volts. So from 22 volts to what is considered fully charged, one would have to put in back 150 amp hour. Today we put in 60 amp hours, so we minus the 60. So for tomorrow, for example, we take 150 minus this number, so there is 90 amp hour left to put back into the battery tomorrow. So this is how it works. There is a characteristics in the battery that one has to understand when a battery is fully charged.